Okay. A woman can swim at 5/8 in still water. She swims across a river of width D. She sets out at right angles to the bank. So what does that mean? I think she's going for the fastest. I think she's going for the fastest way possible, isn't it? Just aiming all 5/8 across the river. Okay. The current flows parallel to straight banks and flows at half a metre per second for the first part of her journey, and then changes speed for the remainder of her journey. Okay. It says first part of her journey. Doesn't specify equal times, does it? That makes sense. Doesn't specify equal times. So let's call this the red part of the journey. Red part of the journey is here. Blue part of the journey is here. And what we're seeing is that there's two different angles at play there, isn't there? Because the current increases. Next thing we're noticing is they're not equal times in my opinion. There's nothing to say that they're equal times, is there? So I'm just going to keep looking.
Sure.
Yes?
I'm pretty sure you don't need any of that.
I know, I'm just, I will get there. I'm just drawing what actually, everything on the board actually happened though, didn't it? So there's nothing wrong on the board. So as I dissect the question further, I might be able to get rid of any relevant information that I may or may not need. Okay, so that's where I'm at currently. I'm only at this part here and this part here. Okay, she starts from point A, happy days, and the current changes when she reaches point B. Awesome. Then she lands at point C. Great. She finds out when she reaches her side, she is drifted downstream in a distance equal to the width of the river. So essentially, we start here. It's D up, D across. Okay. Now, B is a distance x from the bank as shown. Find x in terms of D. That is tough. Find x in terms of D. Now, I'm not going to lie, if I got this in a leaving cert, I'd be thankful for my option. I probably would have read that and said, not today. Rel doves out the door. And I would have went elsewhere because I haven't seen a question like this ever. Okay, so let's see what I could have done. Now it's worth 20 marks, so I would have got my first 60 easy, but then trying to get anything else is going to be quite difficult. Okay, so what am I thinking of doing here? All right, I would say T1 and T2 respectively, that one of them takes time T1 and the other one takes time T2. And you know what most of us would have done what? When we all have gotten the two velocities relative to each other, we would have got the relative velocity of the first one and we would have got the relative velocity of the second one. And as Mick is saying, he doesn't feel that that's necessary for this question. It isn't, but would any of us actually know that? I wouldn't have. Alright, I can tell you that much. Now, D across, D up, then it's X this direction, right? Let's just take the direction. Your direction going upwards never changes, does it? Does the 5/8 ever change? Aiming straight upwards. So, we can say that T1 is X divided by 5/8. Is that alright? That's how long it takes to go in that direction. T2, anybody? So what vertical distance is it from here to here? It'd be D minus X, wouldn't it? Over 5/8. Okay, so we'll check with this, alright? So they're saying, and the total speed multiplied by time. Speed multiplied by time has to equal total distance, is that right? So T1 for me is 8 over 5 x. T2 multiply top by 8, I'm going to get 8d minus 8x all over 5. Reread the goal of the question. Get x on one side, get d on the other side. Alright. Then you're thinking total distance, d, in that direction. Total distance equals the individual distances added together. So distance A plus distance B. Now, distance A is essentially how fast did you travel in the first section, okay? So, if I do 5/8, oh dear. Yeah, I'm on a loser here. Guess what's going to happen to me there? I'm just going to end up with the same information. I'm just going to end up with D. I'm just going to end up with D equals D. Saw that coming, right? So, I've reused the same information twice, right? So, I have to abandon that route. And then, so, me doing this here was only going to lead to D equals D. Okay, so we're going to follow the marking scheme now at this rate. So once I realised that happened to me, that's not a good thing. So let's try this a different way. 5/8 times T1 gets us this far, and then 5/8 times T2 gets us the rest of the distance. Okay, so your distance D equals 5/8 multiplied by T1. So 5/8 is your upward speed times the time you're travelling upwards, plus 5/8 times T2. We'll get a, I suppose we'll get a 8D equals 5T1 plus 5T2, and we get a quadratic there, okay? So that's one of them. Now, the next one's going to be, no idea why it does that. Alright, so I can safely say the two of them don't seem to be the same equation. Just give me a sec. I'm just going to leave it at that one there because I can't make, I actually don't know where to get that 2T1, 2T2 from yet. So I'm just going to keep going back up again. Now,
I think it's just to make it a simultaneous, so you can notate
if you multiply across by 8, what happens?
Yeah,
You get 5T1 plus 5T2 equals 8D.
Yeah,
And then if you divide it across,
multiplied by 2. So it's just to make it simultaneous later.
if you divide across by 5, you get T1 plus T2 equals 8 over 5 D. Don't know why they multiplied by 2.
It's for the simultaneous later.
Yeah, but you wouldn't know that ahead of time. So you wouldn't know that, yeah. So you'd be at this stage here. So that's the first simultaneous equation. Is that okay with you guys? The next one, we're looking at how to find the distance D. Now this was where the horizontal component comes into play. We've already used the vertical component, haven't we? So we've used the 5/8 and we've used the time. Now we've got to think about this, alright? What do we know about the distance going across? It's distance D, isn't it? So to get your first distance, which I'll mark in green, okay, your distance D equals a half T1 because it travels that direction at a half a meter per second, and you multiply that by the time, and then you have this part here, which is going to be 1 T2. Is that alright? Now if we multiply both sides by 2, what you get? You're going to get 2D equals T1 plus 2T2. So 2D equals T1 plus 2D2. Right, and that's where we got that piece of information from. Now, we're after distance x, aren't we? Distance x is the vertical component which happens in the time frame t1. Makes sense that we isolate t1. So let's isolate t1. Okay? So as Mick said earlier, you're going to know that you're going to have to multiply this by 2. So I'm going to multiply it by minus 2. So I'm going to get minus 2t1 minus 2t2 equals minus 16d over 5. I'm going to get minus T1 equals, what's it, 16 over 5 take away 2?
6 d over 5.
What?
It's 6 over 5.
Oh, thank you. Minus 6 over 5d. So T1 therefore must be 6 over 5d. Now if you reset to the start of the, if you restart to the earlier question, it's a distance x. You're aiming up at 5/8. That's the only part of the velocity that contributes to that distance. So it's your distance is going to be 5/8 T1. Sort of what we had earlier, and then D is going to be 5/8. Sorry, I say D, but it's actually X. It's your distance going upwards. So it's 5/8 times T1, so 5/8 times 6 over 5D, and that'll be X equals 3/4 D, and you're done.